रिकॉर्डिंग चल रहा है।
Shall we start, sir? Hello, sir. Am I audible?
Yes, Sadhanand, please start. Yes, you are audible. Please start.
Am I audible, sir?
Yes, Sadhanand, you can
Okay.
start now. You are audible.
So, good afternoon, all. I am Shraddhan Verma, research scholar in MNIT Jaipur. So, I am here to give the practical experience how we will simulate the patients using UVA Padova type 1 diabetes simulator. So, we are assuming that simulator has been installed in your system. Now, what we have to do? We have to go into the folder where your simulator has been installed. Let our folder is this.
Sadhanand, your screen is not visible. Sadhanand, your screen is not visible. Please share your screen. Now it is visible.
This folder. So in MATLAB, you have to be there in this folder. So currently I am here. So in the command window, we have to type simulator. In simulator, S should be capital letter and press enter. So this pop-up will open. This is the graphical user interface window. Here already in the right side button is already red. It means no scenario has been currently uploaded. If by mistake it is green, then you have to clear it. Then it will become from green to red. So there are three options in the load scenario: select scenario files, use GUI to create scenario. So by clicking on this select scenario files, there are so many options already existing scenario. What is scenario? In this scenario, one minute. Just go in this section so that you can see the file. Yes. In this pop-up, just click on, sorry. In this scenario, what we have given? We have given the distribution of meal when we are taking meals at 7 a.m., 12 a.m., 19 a.m. Next day, after 24 hours, 7 a.m., 12 a.m., 19 a.m. And what is the time of meal? Particular, it's 7 hours. And amount of meal 40, 50, 70 gram. Okay, these things are written in the .scn file. So how we will load? Click on this and select a particular scenario. Let us consider that we are selecting this scn this file, and we have to click this arrow button. So file will be loaded here in the selected scenario section. From available scenario section, file will be uploaded into the selected scenario section. Then we have to click on the return to main window button. Then you can see that the signal red indicator becomes green. From red to green, it indicates your file has been uploaded into this simulator. So next step is how to select the patient. In the select subject sections, 33 patients are given, in which for each and individual category, adolescent and adult and children, 11 patients are given, and one patients in 11, 10 patients one patient's based on the average value of all 1 to 10 data. I mean, we have 10 patients for the adolescents. So taking all values in average, we have generated the adolescent patient. Same we have done for the adult, and same has been done for the child case. So let us consider that we want to simulate for the adult one. So click on this and click on the add button. So when file is uploaded into the right portion of the window, then indicator becomes green. It indicates your file has been uploaded. So right now we are just selected one patient. So we can select more than one patient. And with the help of remove button, we can remove any patient if you do not want to currently simulate. So just I am for current time, I am using adult 001. So both should be in the green. Indicator should be green. It indicates scenario has been uploaded and adult has been uploaded also. In the hardware section, there is a button built in. So by default, the IV is selected. You can select IV, SMBG, and CGM by just clicking on this. We can change the sensors. There are 3 sensors, IV, SMBG, and CGM by the software provider. So I have selected the IV sensor. Here pump, in the pump section by default generic is selected. You can select no sensor or noise and error sensor. So actually IV, SMBG, and CGM is totally based on the devices which is existing in the market. In the background, mathematical equations is written, which is completely based on the behavior of the real existing device. IV, how IV will behave, how SMBG will behave, how CGM behaves. So currently by hardware section, we have selected built-in sensors IV and pumps generic. If you want to add your own file, then from the file section, select hardware files. By default, some files are there. We can also add pump and sensors here. You can also write the code for this by observing how can we write. By seeing these examples, we can also write for the code for the pump and sensors. So you can write, you can load your own sensors and spam from these sections. So currently we are using IV sensor and pumps. Then next section is pre-test screening. It should be none. And this is another test, defined metabolic test. It is not required here. This is used for the clinical, different other trials when you have the clinical data to verify this. So for this simulation, this is not required. And outcomes in the outcome section, select this button. New pop-up will appear. In this pop-up, we can see outcome measures is given. Your target range is by default given 70 to 180. If you want, we can change it. We want to 75. So you can change it. Okay. Just now I am using 70 to 180. Anything, if you want to 170, you can also change it. Okay. So this is customizable parameter. Any users can change as per your need. So by default, mean blood glucose value checked. So it indicates for the whole simulation time period, what is the average value of blood glucose, percentage reading below the target. It indicates below the target, what is your target? 70. How much percentage of time your reading is below the 70 mg per dl? How much percentage of time your reading is below the 180 mg/dl? This parameter indicates. And this thing, percentage reading within the target, how much percentage of time we are within the 70 to 180 mg per dl. So as per your need, you can check, and when you click on OK, by this setting, you will see the result and you can save it. So here I have also here in the graph section, blood glucose risk trace, aggregated BG trace, and histogram is given. So I want to use see the graph of this. So I have selected this blood glucose. and trace. Okay, this will give the time versus glucose reading. Okay, if you want to check the point care plot, you have to click on this. Okay, with this setting, I am going for the simulation. So blood glucose selected, trace is selected. Here blood glucose risk index is the index which indicates whether patient, if this value is between 0 to 2, it indicates risk is low. If blood glucose risk index is high, it indicates the patient should be high diabetic case is high diabetic. Okay, then by clicking on OK, this setting will be saved. So loading scenario is okay, adult is okay, sorry, select patient adult is added, and hardware section is added, and I have also saved this, and it should be checked. Then you will get the pop-up so that we can save with different name, save results as text. Okay, then now what we have to do, we have to click on the run simulation. It will take 2 or 3 minutes. So we are going to simulate based on this scenario. Here when you select scenario, file is uploaded from here is this section. So I have just shown this file to consider what is going on here. Okay, this data is loaded in the using this scenario section. Okay, now click simulation. It will take nearly 2 or 3 minutes. Type 1 diabetes simulation in process, please wait. So now see, because we have checked save results as test, so results here it will give the total percentage time below the target, percentage time below the upper value, below the lower value, and mean value. These things are given in this text. First see the trace. So first we have to save it with today's date 04102025. We have saved this now. Okay. This is the complete closed loop simulation. We have given food at a particular this time, say at 7 hour. So when food is provided, glucose value is increasing. Again, because of the controller is there, glucose value getting down. And again, we are giving food at 12. So glucose value is also in, then again increasing. Then at this time, at 19 a.m., we are providing dinner. You can check it from here. 7, 12, 19. So the graph seven 12, 19. Okay. 15 hour out of 24 hour, 7, 12, and 19. So here food is given. So results like this, it means here results is for near about 30 hour. Results graph are shown for the 30 hours. So for the different setting, we can generate for the same patient, we can generate a different time versus glucose graph. How the patients behave for different food intake. Okay. Now again, we can close this and go to the result section, because I have saved one file also in the result section for today's date. This one. So patient ID is 001, setting is saved in very short format. Blood glucose, sorry, mean is here. Second value is this. Mean blood glucose is 125.91. Again, this third value is percentage time below the low. I mean, below the 70 mg per dl. The graph never goes below the 70 mg per dl. So there is, it is 0. Percentage at time in the target, most of the time graph was within 70 to 180 mg per dl. That's why it is 98.50 times. Okay. Percentage of time below the higher threshold. So percentage of time below the 180 mg per dl is 1.50. And blood glucose risk index is 0.89. Based on the graph, it calculates the blood glucose risk index. It indicates the how much care, what is about the condition, critical condition. So if actually this parameter is based on the combine all the parameter. If blood glucose is low and percentage time below the low target, percentage time below the high target, and percentage of time below the within the target. So single using this, we can say risk is low. If this value is near about more than 2.5, then risk is high. So this simulations for the adult 001. So next, how we can see others files related to this, and go to the sim result mat. Sorry. Yes. So here in the workspace, click on this. So here results. In the result section, glucose value is given. So based on this, the plot we have seen earlier, reading is saved. Sorry, reading is saved here, and plot is shown because we have checked the plot. So 112. So whole for complete simulation length. You can see the different value of glucose. So if you want to save at different place, you can just copy and paste in your Excel. So again, you can plot this. Okay, same plot we have seen during simulation. Okay, so this is the glucose value. Again, if you want to find out base CHO, yeah, because CHO meal is given at a particular time, not during. Meal is a event based parameter. We have given me meal at 7, 12, and 19, as I have shown you earlier. So other at other time this value will be 0, and at particular 7 a.m. You will get the mean value. So actually within 15 minutes, so within 15 minutes we have to dissolve this. That's why for the 15 minute same value will appear. Again, this value 1, 2, 3, 4, 5. So if you'll check this, there is total 15 time instant, sample instant. Again this. Okay, so we can save the different, we can see the different CHO amount. CHO means carbohydrate value, and we have seen glucose. Where is glucose? And insulin reading for the closed loop, insulin reading will be saved here, bolus and basal sections. Let's just open this. Okay, insulin days is 122.37. This, and by clicking on this, actually for the closed loop, for the open loop, basal and bolus is given in open loop. Formula for basal and bolus is different. For the closed loop, controller give the basal and bolus dose. So In the result section, we have seen glucose, CHO, percent ID is here. And these are the settings by default. This is used. There is no need to disturb this. If you want to, you can change it. Initial blood glucose 112.50. Otherwise, by default, it execute the closed loop simulation based on the saved setting. In the pump section, if so glucose reading, basal and bolus dose. In the PEP section, if you do the open loop simulation, then data will be saved here in the pump section. When we execute open loop, by default, earlier existing file will be replaced by new file. So we have seen the readings because I have run the program in the morning. So results by default saved here. By default results all well here. And okay. And here in the scenario section, your all saved scenario, your own generated scenario is here. And by default, the software provided these scenario CL close. OL means open loop. And we can see by clicking on this file will be opened here. Okay. Other .p file we cannot open it because it is in the protected mode provided by the software company. So we cannot even open it. We cannot we only open that .mat file where .mat extension. So for our purpose, this is only useful. Sim underscore result.mat, where all results are available, like a glucose value, CHO value, basal, bolus, other things. And and another section here is the scenario. Every scenario is saved here. And this is the result section. This is the result section. I have shown this file. This file is saved here by default. If you will not change the name, existing file will be replaced. Okay. If you will not change the file which is pop up during the simulation, so earlier file with same name will be replaced by the new file. So that's why I have changed the name by date and something 0001. So these are the outcomes which appears after change select outcome measure sections. So because we have selected only mean blood glucose percentage type below the low target, so we can see only these. Okay, so let us consider for different patients. So again, what we have to do, we have to just back it here, because default folder should be this. So just type CLC, it will clear the command window. Again, just close here, because it is green. Just click on this clear scenario, it will become red. So remove it, it will become red. So indicator indicates there is no existing file here to be simulated. So again, we will start from the fresh. So next consider the how we can generate own scenario. Not we in this section now we are using how we can generate own scenario. This when we click on this use GUI to create scenario, this pop-up will appear. So scenario name is this. Again, if we save this scenario, we save this name. So the file which is already present in the folder template1 will be replaced by this. So therefore, just change the name 0410. Okay. Length of the simulation, 1400 means divided by 60, it will give 24. It means we are going to simulate for 24 hour. Even we can do for 2 days. So then we have to multiply it by 2. So what is closed loop? Start of the closed loop. If it is 0, then simulation, closed loop simulation. It means uh, in this background, controller is there. Controller calculates the amount of insulin dose. So when it is 0, it means controller is working. When it is not 0, it means the internal open loop will simulate the glucose reading. I mean, open loop will simulate the amount of insulin dose, which is the part of the basal and bolus. Okay. And closed loop warm up time, it is mostly 0. There is no need to give 1, 2, 3. If you want, you can provide the minutes. So it will take some time, then it will start. Initial blood glucose, we can provide your starting point of blood glucose here. If note one thing, if we do not provide any value, then by default, which is saved in the MATLAB, it will execute. So we are not providing here. Just our whole intention is we to calculate the simulation for the closed loop. I will tell next few after this how to simulate for the open loop. Here it is 0 because we want to do the whole closed loop simulation, and this is subject specific basal, subject specific carbohydrate to insulin ratio. In the subject sections, uh, correction factor and carbohydrate to insulin ratio is given. So when we select a subject like adult 002, adult 003, based on the CHO to I ratio of that subject will be loaded here. There is no need to manually write here. When we load the subject accordingly, it will by default utilize the value of correction factor and carbohydrate to insulin ratio, everything of that subject here. So check, we are going to simulate for the breakfast, lunch, dinner for the whole day. Here the option generate 1 day, generate for 1 week. We are going for the 1 day. Okay. So these settings are there. Okay. Now save this. We have to save it. Let us see. Here is red and we have to save it. Save and generate scenario. First we have to save it and generate scenario. Then it will become from red to green. Okay. It is loaded. Okay. File is saved here and loaded here. Signal just changes from red to green. It indicates file has been uploaded here. Okay. If you want, we can see also this file. SV, this one is our generated scenario, closed loop 0. In .scn extension, where is the percentage sign? It means that line will be executed. Okay. Okay. It means percentage sign line will be executed. T time of close, it means since midnight is the time is 00. So at the midnight, it was at the same time when computer simulation will start, closed loop will work here. T for T simulation, total time of simulation 24 hour. Regulation is 0. Meal is given 7, 12, 16, 18, 23. As we have seen here, as we have in, sorry, because it will give error because we have not the this folder, so we cannot go back. Just as we have seen, we have given the meal at 7, 12, 16, 18, 23. So this T meal is time of meal and unit of this time is hour, and A meal is amount of meal, and D meal is what is the duration of meal. We have to finish this meal within 15 minutes. Okay. So 45 hour unit meal, 70 unit meal, 20 gram, 80 gram and 20 grams. Breakfast, it means 12 at lunch, snacks, and फिर dinner, and at the midnight at 23 p.m. we are giving 20 gram meal. So these are the settings, quest base, basal, and quest base bolus. It means patient base because we have already selected the patient based parameters. So by default, it utilize this settings. Now next, so we have seen how GUI can be used to generate the scenario. Now scenario has been uploaded here. So one thing we can note that there is no way to check which scenario has been uploaded in this software, because when we have uploaded the file by checking from the list, the scenario has been saved here, but file name is not appears here. So we have to keep in mind which file we have uploaded. I mean, on basis of which file we are going to simulate. So you have to keep in mind this is file name is not visible here, but file has been loaded because signal is green. Okay, let consider the adult case, adult one, sorry, child one. So because we are not at this section, that's why this is giving error. Now it will not give the error. Just children, child 001, add this. We have added here, signal become, indicator turns from red to green. Now other things are same. We are not going to change because if you want, we can do it. Sensor is IV sensor, generic pump. Here we have to again click on this, and actually when we click on this, previous setting appears. By default, it takes previous settings. Okay, in previous we have selected this, so that's why these settings appears here. So click on OK, and save results at text should be checked, and again run simulation. So process is running here. In for the child case, we can see here we are simulating for 1440. In 20 for the 24-hour, we will see the plot. So this is the plot for child 001. So just we can save this figure also. 1 minute. So first we have to save this. So okay. So file will be saved here in the result section. So go to the result section. This file. Lecture चल रहा है. Okay, ma'am. This is our current file which we have saved just now. So देखिए, we can see this is ID, child ID. Child ID is 001. Mean blood glucose is here. We can just open the this one. Okay. Child ID, sorry, ID child. So mean blood glucose, we can just place tab button. So this value is mean VG is 173.15. So the software directly calculates blood glucose, all reading of blood glucose divided by number of samples. So it will give the mean glucose value. We can see mostly blood glucose is more than 123. Sorry, y-axis is 123, near about 123, above. This is far a very mostly more than 123. So average is, we can see average will be more than 123. It is 173.15. Then again, what is the percentage time below the low? Just see the graph. Below the low is what is our low glucose value? We have kept 70 mg per dl for low blood glucose value. So in the graph, if we draw the line 70 mg per dl below 120, there is no glucose reading below 120. It means below 70 there is no reading. So that's why percentage time below 70 mg per dl should be 0. That's why here also is 0. It means it is correct. Again, percent time in the target 56.28. Percentage time in the target 56.28. Target is 70 mg per dl to 180 mg per dl. So this 180 to above is not our target. So we have to calculate this section. And 70 to 180, how much percentage total time when it is in our desired zone. So directly it is giving 56.28. Percentage time below the high, it means above 180 mg per dl. What is the time? So x-axis we have to calculate the time if we want to do manual, and divided by total time, then it will give the percent time below the high. 43.72. We can just see this 180 x, sorry, x is time 7 to 11 hours. Between this, y is more than our desired value. Between 12:55 to 16.2 is out of desired range, and between 18 to 22, this glucose value is out of the desired range. So it will calculated the percentage time, which is almost 43.72. Okay, again, VG risk index, because as I have told you, risk index based on considering all these things. This is in the background formula is there, risk index, which calculates, which is based on the readings of the blood glucose. So most of the time here 43.72% of time it is out of the desired range. So that's why it is also high. In previous case, percentage time below the higher range is low. That's why index is also low. So here is a, there is a, this is the critical case, because risk index is very high. So using this parameter, we can directly say patient blood glucose most of the time is not into the our desired range. So this is a very important parameter. So thus, this is for the child case. Okay. So in the graph, we can also save it here from just for click in add save as. Anywhere we can save it in the result section. Just in the mostly we save the things in the result section. So save. We have made own scenario. So okay. So we can save it. So anytime we can utilize this file is we can see file is available here, child 001 underscore sv. Okay. So when we close this, it will close again. If you want to anytime, we can just, there is no need to do some lesson again. We can click on dot figure, sorry, this file, but MATLAB should be there, and we can see this whole graph. Okay, this is the for child case. In case of child, mostly zigzag is there. In case of adult, there is leg zigzag. This because inherent nature of the glucose behavior of glucose in the child. So again, we have closed this. We have to close this again. So we have seen the experiment demonstration practical experiment with using child 001 and adult 001. And we have also seen the demonstration how to use the select scenario, how to use the create scenario. Again, one case is left. What is open loop and closed loop? Here, whole thing is closed loop because, sorry, 1 minute. Just clear it. Why it is closed loop? Because why the whole simulation is closed loop? Because it is zero. Let us consider we want to do for open loop. In open loop case, exact formula is given to calculate the basal and bolus dose. So based of the food amount, meal amount, it calculates basal and bolus dose and provide to the patient or patient or child adult, which is child adult and adolescent. So now we are moving for that case. How we can do? Just close it, just clear it, remove everything. Okay. Now we start with fresh. Use GUI to create scenario. Click on this. Five. We are going for the open loop. That's why this time should be more than total simulation time. So for more than this, by default, 1440, it should be more than this. So we are using 2000. Any value more than 1440. 2000, 1500, any value we can put it. So here we can write open loop simulation. So please note that if the start of closed loops, this value is more than this, then and we have to select also this. So it will behave as open loop system. So here controller is not working. Mathematical equations are written for the calculation of bolus and basal dose. So on the basis of this, we will get the whole simulation for the given duration, for the given length of time. So this should be more than initial length of simulation and it should be checked, fixed bolus. Okay. If you want, we can also select this. Otherwise, it should be based on subject specific. And let's, okay. So what we can say, if 45 amount of meal, mostly it is divided by 15. So bolus dose is 370 divided by 15, 4.7. Okay. So bolus dose is calculated here. Okay. Now we have to save it, save as CM, and if you want, we can manually change it. Otherwise we will not see the very much difference. We are putting your own bolus. Mathematical formula is there. So we are changing because we want to see the difference. That we are keeping 8. So save scenario and generate scenario. Scenario is loaded and take the case of adult, same section. Okay. This is already selected. We have to keep it, just run simulation. Okay. You can see. Okay, because we have not given the proper amount of insulin. That's why open loop. So we have not given exact amount of insulin which is required here. So that's why they give most of the time it is below 70 mg per DL will be here. So I think simulation enters into the hypoglycemia case below the low glucose value 70 mg per DL. So that's why we can see the difference of open loop and closed loop. if we provide the calculated amount of insulin in case of open loop also, we will see the almost not exact, but uh, a good result, not like this, but result will be good when we provide a proper amount of basal and bolus dose. So this I have modified the settings to show what will happen if we do not provide the required amount of insulin. Then what how the glucose versus time curve appears, how the simulation curve appears. So here the I think this is the very critical case. We will see the BGI index will be very high because most of the time we are below the 70 mg per DL. So we are closing this figure, and if I think, I don't know, we have saved this figure or not, text figure. Okay, again we can simulate it. Yes, no, this is not result. Yes, this result. Yes, we can see this. We have this file name is this open loop. So we can see the blood glucose is blood glucose index is very high, 7.2. Other things are percentage mean blood glucose 172.74. Even mean should be near about 130, 120. And percentage type below the target is, I think I have opened wrong file. Might be. Okay, percentage below the low. So okay, if you want, we can do the again simulation. Yes, yes, this file. Percentage mean simulation is 80 and percentage at time below the low value 34, because as per the graph we can see most of the time we are below the low target value, and blood glucose risk index is high because very less amount of time we are within the target range. We are within the target range. 1 minute, just tap button. This is mean blood glucose. BGI index is 11.11. So we are not above 180 mg per DL. That's why high percentage time below the high target is 0. As per the graph, we can see we our graph never goes more than 180 mg per DL. That's why this reading is 0. And blood glucose risk index is high because most of the time we are below the lower target value. Hypoglycemia, we are in the hypoglycemia range. This is the open loop simulation. In open loop simulation, most of the time we are either we are below the target or we are uh, above the target. It takes most large amount of time to settle near about set point. That's why we use the controller give which settles the glucose value near about set point, or which brings back the glucose value within the uh, desired range in a less amount of time. So this is the importance of the controller. So now I have explained everything which is required for the software, how to simulate for different adult and children case. Same we can simulate for the adolescent kid. Adult is, I think, near about age, child is age near about uh, below the 10. Adolescent is 10 to 20, we can consider, and adult more than this. So now we are closing this. So so thank you from my side. If you have any query, you can ask. If you have any doubt, you can ask. So next session will be started as per the schedule given into the mail. Thank you all.